still looking at stats and probability number 5, which is analyzing scatter plots. But the good news is this is the last learning target. So our final one is I can use the equation from the line of best fit. So going back to LT3, making the line of best fit, LT4, finding the equation, but now we're going to use the equation to both summarize and make predictions about the data. So let's get started here. So the first question says, several members at a gym were asked how many minutes they worked out at the gym that day, as well as how many calories they burned. Their answers were used to make the scatter plot on the right. So here's all the data from the gym members that they asked. So for example, this person worked out for 70 minutes and burned 500 calories. This person, we'll go above here, worked for 30 minutes and burned almost, I'd say, 550 calories. So the first question is, or what we need first is to write the equation. So to write the equation, same steps as before, find my slope. So I'm going to look here. It looks like 0, 0, but I'm just going to leave that one because I don't like to do the y-intercept. This one's not a bad point. So 20 minutes, 300 calories. And this one doesn't look like a bad point, so we'll pick that one there. So 40 minutes, 600 calories. So I'm just going to use rise over run since it gave me, a lovely graph, and it's pretty easy to read here. So the rise, so you can look at 300 calories up to 600 calories, which would be 300, or you can count boxes, and it looks like each box is worth 100. So 100, 200, 300. And for our run, I said I think 20 minutes up to 40 minutes, which would be 20. Or if you look at the box, each one is worth 10, so 10 and 20. So my rise was 30, which in this case would be calories, and my run was 20, which would be minutes. So if I divided that by 20, actually, I apologize, that should be 300. If I divide that by 20, 300 divided by 20 is 15. Of course, 20 divided by 20 is 1. So my slope is 15 over 1. My y-intercept, I think it's 0, 0, but I'm going to prove it mathematically here. I'll use the point 20, 30 to help me out, or 300. I keep calling it 30. 20, 300. So y equals mx plus b. So y is 300. My slope I just found was 15. My x is 20, and my y-intercept is unknown. So 15 times 2 is 30. Add the 0 would be 300. If you wanted to subtract 300 to solve for b, and I get b to equal 0. So I was right in my guess, which makes mathematical sense, as you can see it kind of crossing there. So my equation is y equals, my slope was 15, x is my variable, plus 0. And of course you don't need the plus 0 because mathematically that doesn't do anything to the equation. So what does x represent in this equation? So that x right there, I'm going to look at my x-axis, which is my horizontal, which is time in minutes. So when I do this, remembering x is going to be where I'm going to put in the values for time, and y, looking at my y-axis, is calories burned. So if I'm looking for calories burned, I'm looking for the y, or if I know calories burned, I'm going to plug that in for the y. So my first equation, now that we made the equation, my first question is, how many calories would you expect someone to burn if they spend 120 minutes at the gym? So again, we're using our equation. I know 120 minutes, and if I go back up here, minutes is the x, so I'm going to put in 120 in for that x. So y equals, because they asked me how many calories, y is calories, 15 times 120. So 15 times 12 is 180, and add a 0, or if you need a calculator, that's totally fine, 1,800. So if I spent 2 hours or 120 minutes at the gym, I would burn 1,800 calories. Remember, it's important to label this because they are questions or storylines here. Next one, if somebody burned 1,740 calories, how many minutes would you predict they had spent at the gym? So again, you're going to use that same equation. This time I know calories. If I go up here, calories was Y. So I'm going to put that 1,740 in for Y equals 15x. The question is, how many minutes have they spent? So I don't know my x, which is the time. So it's easy one-step equation here, divide by 15. So x is 116 minutes. Again, use your calculator to help you get that. So the label would be they spent 116 minutes if they burn 1,740 calories. So what does the slope mean? So if we go back up here, the slope is 15 over 1. 15 is your rise, which is calories, which is your Y, and 1 is your minutes. So what is the slope? 15 over 1. What does it represent? People, and this is on average because, of course, this is an exact because you made a line of best fit, burn 15 calories per minute. Okay, other side, what does the y-intercept mean? Well, first of all, the y-intercept is 0, 0. And then what does it represent? Well, 0 is my x, which is minutes, and y is my calories, which in this case is 0, which makes total sense. If I spend 0 minutes, which is your x, at the gym, they are going to burn, of course, 0 calories, which is my y here. Okay, so your first example done. Let's check out the second one, which is the only one. Good news is they give us the equation. We don't have to go find it. So this one's going to be a little bit faster. It says Julian made a scatter plot to show the number of band members at his school over the years. A trend line of a scatter plot had the equation y equals 13x plus 45, where y represents the total number of band students and x represents the number of years since 1990. So be careful, it's since 1990. So x again is how many years past or since 1990, and y is the total number of band members. So how many students would you predict to be members of the band in 1997? That's a year after I graduated high school. So my equation is y equals 13x plus 45. I know the years. So if I go back up here, x is the years, but it's since 1990. So if I'm at 1997 and it's since 1990, that's 7 years. So I'm going to put x as 7. And then I'm just going to solve with my calculator here. So if I take 13 times 7 plus the 45, I'm going to get 136. So the question is, how many students would you predict? 136 students will be in the band in 1997. How many students would you expect to be members of the band in 2010? So again, same question. Since it's years, we go up here. X represents the number of years. So we're going to put it in the same spot as we did on question 5 here. So y equals 13. So since 1990, and if I'm looking at 2010, that's 20 years. So I'm going to plug 20 in for the x. And then grab my calculator and solve here. So 13 times 20 plus 45 equals 305. So in 2010, I would expect to have 305 students in the band. And the last question, in what year would you expect to have the band to be 370 members? So this one's backwards. I'm knowing the years. So this time, I'm knowing the number of band members. So if I come up here, y is the total number of band members. So this equation here, 13x plus, doesn't look like a plus sign. We're going to add 45. 370 is the y because that's students. So this is going to take a two-step equation, which you can do. So if I want x alone, I'm going to take 45 off of both sides first. So 370 minus 45 is 325 equals 13x. Divide by 13 to get x. And grab your calculator. That should be 25. Now, it's not 25 years. This is in which year. So remember, x represents the number of years since 1990. So we're going to take 1990, add 25 years to that, and we have 2015. So in year, back that up. Whoops. In year 2015. So there's examples of now how to use that equation that we found in the last learning target and how that helps us solve equations.